Thank you, Kunal. Thank you, Professor Singh, for the exciting talk and for sharing interesting insights on 3D printing. We have a lot of questions coming in from the audience. We are slightly short on time, but we'll try to pick up as many questions as possible. So I'll start straight away. The first question, Professor Singh, is from a participant who is asking about the sustainability of 3D printing process, whether the process and the applications targeted are sustainable. Could you please comment on that?
Uh, yes, yes, definitely it is sustainable because if even if you Google it, this 3D printing is known as a green technology because wastage of material and use of raw material is less in this case. So definitely it adds to the sustainability in terms of the resource saving and energy also. Like in one run you can print number of parts depending upon the size of your printing bed, so multiple designs, multiple numbers, this can be designed and printed. So definitely it's a sustainability in terms of energy and in terms of the number of parts which can be printed in a single row.
Yeah. Thank you, Professor Singh. The next question is about the prospect of using 2D materials. So, what are the prospects of using 2D materials like graphene in 3D printing?
Yes, as I shown in my slides also, like reduced graphene oxide and graphene has been used a lot in this 3D printing. But now these magazines, metal organic frameworks, and sulfides, oxides, all these are being printed. If we see the literature and recent reviews are wonderful. I would ask participants to go with the recent reviews. Even I have also gone to prepare for this lecture, so they have documented very well, and all types of materials as apart from graphene, these materials are being imprinted. In fact, we are trying. We did not get the result at present, but we are trying to. But of course, with them, you have to make this material in the printable form. You cannot put your powder and it will be printed. For example, if I want to print these magazines, I need to have a binder in it. I need to have add some filler which can provide it's a good viscosity. So ink formulation will be the part of printing these materials. So yes, any material can be printed provided it is a printable and low viscous.
Right. Thank you, Professor Singh. Uh, there's a question from a participant who wants to hear more about 3D printing of biopolymer nanocomposites for tissue engineering applications, and which nanofiller will be best for this kind of an application.
Okay, I cannot say which will be the best nanofillers because it ultimately gets to be known with your performance only. But yes, graphene is one of the filament because it is a biocompatible also. So it is one of the fillers that is being used for this bioprinting.
Yeah. Thank you, Professor Singh. Uh, a participant wants to know about the possibility of achieving nano dimensions by 3D printing, and a follow-up to that is lithography a form of 3D printing in the atomic scale?
Okay, at present, with the conventional or this 3D printing techniques, nanomaterials as this nano dimensions are not possible. This is, we can say, one of the limitations. But yes, with the lithography and other advanced soft lithography, this nano dimensions are achievable.
Okay. Yeah. Thank you, Professor Singh. So you showed a slide on supercapacitor electrodes prepared by 3D printing. So can we tune the porosity of such electrodes? Uh,
Yes, this is the advantage of 3D printing, where we can tune the porosity, we can tune the shape, depending by optimizing our parameters. We need to feed what porosity we want, so that can be modulated. In fact, in one of my slides for that implant application, they were having variable porosity and single porosity. Porosity can be modulated.
okay. Thank you, Professor Singh. We have some interesting questions like, is it possible to print a seed for agriculture?
Yes, now 3D printing is into food printing also. I missed to include that food printing. Yes, nowadays it is possible. Only the thing is, for seed printing, you have to understand their biological aspect, biological components. It is not that you put the powder and it will be print, because in the cells, what cells are responsible for that seed, you need to generate those cells, and then you can do printing. And other than printing also, the 3D printing of food is well in the advanced stage. And this application is very helpful for those who are not having this jaw chewing capacity, for old people who cannot. So you can this customize the requirement, viscosity, softness, all this. Food printing is also one of the emerging areas. I missed to include that.
Okay. So just online, like 3D printing electrodes can be tuned based on porosity. Can we also tune the mechanical strength of 3D printed materials?
Yes,
Or
yes.
yeah,
As I told, one option is to use multi-materials, using combination of materials. So yes, mechanical strength can be used, and then lattice structures we can do.
okay, yeah. I'll take a couple of last questions, maybe.
Sure.
Yes, so thank you, Professor Singh. The next question is from a participant who wants to know more about printable hydrogels and what are the parameters that one must consider to fabricate such 3D
Okay,
printed hydrogels.
for hydrogels, personally, I have not worked, but for obviously for fluidicity, or we can say viscosity, that is one of the prime factor which is controlling material for polymers and the hydrogels.
Okay. Could you also comment on the speed of 3D printing? A participant has asked, what is the fastest speed now to print an object by 3D printing?
Speed, I would say that it is about 1000 or 1500 millimeter per second. Uh, just arbitrary this information I have, but for the metal, if I talk about, but for other materials, it can be more or less depending upon the property of your material.
Mhm. All right. Thank you, Professor Singh.
And
So,
again, sorry, with the speed, we will be with the speed we will be compromising with the quality also. What speed you are putting for interaction, laser interaction or polymerization, that is definitely detrimental for properties and performance.
all right. Thank you, Professor Singh. So I'll pick up one last question before we move to the closing remarks. So this is, are bioprinted materials under clinical trials in India, and what is the time period of such clinical trials?
Uh, Clinical trials is a long process, and time, of course, a good amount of time is taken, because it needs a lot of permissions. And in India, this bioprinting is not at that pace which is required. Only at few places this bioprinting is being, for example, in IIT Delhi, it is one of the areas where they are doing for the bioprinting, but it is not at that pace with what is done at the international levels. And clinical validations, uh, very difficult. 3 to 5 years it takes for implants to get permissions and approvals, validations, testing.
Thank you, Professor Singh.
Thank you so much. Thank you, Dr. Singh. Thank you, Mihir, and thank you, Sharmishta, for that wonderful lecture and for the wonderful Q&A. I know the audience is still raring to go with many questions, but time is
Uh,
always of a limit.
you can share, my email is there. So any
Okay.
participant who has queries, they are free to connect me through the LinkedIn, Facebook, Insta, Twitter, personal email. So any mode I'm active. You will find me in social media. So, and in email also, you are most welcome to interact or to discuss or to collaborate.
Okay, well, that's great to know. I think I'm sure the audience would really love to connect with you. Some very interesting applications you have shown today. So, this brings us to the end of today's session. We hope that you have enjoyed this broadcast. We invite you to view the edited recordings from the past events in the ACS Science Talks library. At the end of the session, you will receive a brief survey. Kindly share your feedback with us so that we can continue to improve and serve you better. The link for the survey has also been placed in the chat box. So I'll really request all of you to take that survey for us. And on behalf of all of us at ACS, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and healthy.
Yeah, thank you, Kunal. Thank you, participants, and thank you, ACS team.